All right, so today we're going to jump into section 3.1. This is going to be taking just a little bit of a deeper dive into the metric system. So for the most part right now, as you see here, we'll switch over. The notes on these sections are relatively straightforward. It's going to be pretty much a repeat of almost, I would say for the first 3.2 through 3.7 is almost identically the same across the board. There's a few nuanced differences, especially when we start to get into current with electrical current, things like that. But for the most part, there are going to be a lot of similarities between these sections as we move forward. So just want to point out really quick that the base metric units that we'll pretty much be looking at are going to be meters, kilograms, seconds, amps. Kelvin is temperature. Candela or candles is kind of like another way of indicating its light intensity. You can use that in kind of in terms of the smaller kind of quantities that you see, like however many, like your flashlight has a certain number of candles to it. But also we use that in kind of like stellar terms, so stars, right? The amount of candles that they produce, and then moles is kind of like a molecular substance. There are other ones that we are going to use quite a bit, like liters, cubic meters, and square meters. This is, again, like volume and area. Newtons and meters per second for force and speed, and then so on and so forth. Radians, I don't think we're really going to be dealing too much with until near the end of the semester, actually, when we start getting into some of the more basic trig concepts, trigonometric concepts. Man, I cannot talk today. Okay, so this is the prefixes for the units that we're going to be utilizing. Okay, so what I want you to do is pay very, very close attention to this chart, because you are probably going to be referencing it quite a bit throughout this chapter. In fact, it might not be a bad idea just to print this off and have it handy as you're working through homework problems, because making conversions between one unit to another is it's pretty common, actually. Okay, so that's just something to keep in mind. All right, let's just go ahead and this is also another thing too. For the basic common metric prefixes that we're going to be using, it's the kilo, hecto, deca, base unit, deci, centi, and milli. There's actually a saying that will help you remember it, and that's King Henry died by drinking chocolate milk, which that's ridiculous. I don't think that's historically accurate, but in any case, it doesn't make a difference. It doesn't have to be historically accurate as long as you can remember the prefixes. So King Henry died by drinking chocolate milk. You've got your kilo, your hecto, your deca, your base unit, the by, drinking chocolate milk, okay? So we'll actually be bringing this up quite a bit in the next few sections as we're working on conversions, because there's a couple of different ways that we can deal with conversions as they come about. So that being said, let's go ahead and shift gears. We're going to switch over to our notes here. And let me switch to the notes. There we go. Okay. So let's go ahead and get started. The first problem that we're going to look at is we want to first off give the metric prefix for each value. So this is let me write that down. Give the metric prefix for each number. Okay. So in particular, question number 2 is asking us if I have 100, okay? 100. So again, remember, King Henry died by, and I'm going to do lowercase, drinking chocolate milk, okay? So my base unit is going to be right here in teal. Of course, my webcam is right below that here. Let me shift this down here. And we'll cut that and paste it right there. There we go. All right. So King Henry died by drinking chocolate milk. So the one thing that we need to remember is the base unit, and you just have to count the decimal places. So in this case is 1, 2, 1, 2. So in this case, this is going to be the base unit of hecto. Okay, it's got 2 zeros, and I moved the digit 2 to the right, or I counted 1, boom, boom, right there. So it's 1, 2 to the left. That's what the base unit is going to be. Okay. Let's go ahead and take a look at this next one. Say, for example, I've got 0.001. Okay, and you'll notice that because it's a decimal, it means it's going to be smaller than the base unit. Okay, so when we make the conversion, 1, 2, 3. Okay, we move it 3 digits to get to 1. So that would be 1, 2, 3 right there. The milli would be my prefix. So it would be milli. For this next one, this one's a little bit different. 2, 3, 4, 5, 6. So this is a million. Okay. And a million, you can tell it doesn't really work here with the King Henry died by drinking chocolate milk. You can see I'm going to be far off to the left-hand side here. Like it's not going to work at all whatsoever. So what I need to do in this case is to bring back this chart here and just kind of compare on the left-hand side the decimal form. So you can see right here 1 million corresponds to 10 to the 6th, which is mega. Okay. So this right here would be, need my pen. There we go. This would correspond to mega. Okay. All right, let's do some more. These next ones, we're going to give the SI symbol that corresponds. So for this first question, number 10, again, these are all out of the back of the section, so you can go ahead and take a peek at them. Kilo is always going to correspond to a K. Okay, that's going to be a capital, actually. So if we look at it, actually, no, it's not. It's a lowercase. My bad. See, I make mistakes too. How about that? It's good for you to see my mistakes. All right, 14. This is going to be deca with a K. It's kind of a weird prefix. So again, we'll go back, reference it. Deca looks like it's 10. So it'd be DA would be the prefix, DA. And then 16 for mega. Mega would correspond with, well, we just did that one. 1 million. Whoop, zoomed in there. Didn't mean to do that. Whatever, it works. Mega is going to be a capital M. Okay. And so that would be the corresponding piece specifically for that guy. All right, let's go ahead and continue on. So our next example, let's go ahead and write the abbreviation. See my pen. Right. The abbreviation. Okay. So for question 18, the abbreviation, they're asking us to put in 125 kiloliters. And you're probably wondering to yourself, like, why do they spell liters like an R-E? And they do the same thing. In the textbook, they actually spell meters kind of like M-E-T-R-E-S. It's a very, like, I don't know, British way of spelling it, which is kind of where the whole metric system was devised. So that's part of the reason why we spell it that way. I guess like the more common American spelling is like with the ER at the end, meters with an meters. But for the most part, they're going to be spelling it just like this, okay? So the corresponding abbreviation, what you do is you put the prefix in front of it, the K, which is the kilo, right? So this is going to correspond to the K. And then the liters is going to be the capital L in this case, right? So you're kind of combining the prefixes and the actual, I guess, units that you're really looking for. 21. So here's another one. If I have 36 micro amperes, okay. Micro, this is one of those kind of special ones that if you look at right here on the table, sorry, I know it's kind of backwards, the coloring, but it's actually this is a Greek letter. I don't know if you can see it, this Greek letter right here. Can you see my cursor? Oh yeah, there you go. So it's this Greek letter that is called mu. It's a Greek letter called mu. So this is 36 mu. It's kind of like, almost looks like a cursive M in a way, but it's really not. And then amps is going to be capital A. Okay. All right, and then the reverse, so we were writing the abbreviation, so now what we need to do is kind of do the reverse. So we're going to write what's called the SI unit. That's what these are referenced as. So if you go back in the notes, okay, I need to get this back to, come on, 100%, there we go. Oh, geez. Yeah, but in the section, I should mention really quick, of course, this is like crazy. Let's go 200. In the section itself, I would encourage you to go and take a look at the content, because there's a lot of history that's listed for how the units came about and why it's actually called the SI unit. And so I would go ahead and do a little bit of that reading. It's just really, really good and handy to know that stuff. So we're going to do the units. I'm more interested really not in the history of it, but more in just kind of like how to make some conversions and what these specifically work out to be. So in this case, suppose I've got 24 PS, okay? So you can always go back and take a look here at what the P is. P is pico, okay? So this is 24. And then the S is the units that we're looking at. And you can see that it's going to be a second, which is time. Picoseconds. Okay? So that's a pretty small unit of time that we're dealing with in that case right there. Question 30. 9. Come on. 9. I know what you're thinking. 9 damn? Really? Yeah, I don't know. Okay, I guess that's going to stay there. 9 damn. But pretty much what we're doing on this case is we're looking at the prefix, which is the DA. Okay, the prefix is going to be this guy right there. So what we do is we'll bring the 9 along, and then we look for the DA down in the prefixes. So that's going to be deca, and then M, you may already know what this one is, but it's going to be meters. Okay, so this is decameters. I have to get used to spelling deca like this, because when I grew up learning the metric system, there was, I spelled it like this, deca, with a C, not with a K. So it's a bit of an adjustment for me. I'm just going to be completely honest. 34. If I have 75 MW, those of you who are in renewables will probably know what this one is. But if you look, M is going to be a mega. Okay, so 75 mega. And then the W is going to deal with watts. It's a unit of energy. Okay, so there we go. There's the process that we go through for making these conversions back and forth. A lot of it is mostly like linguistics in this case, just understanding the different prefixes, the particular units and understanding specifically what the abbreviations for those things are. So this wasn't terribly long of a lesson, but that's probably how these ones for the next, I would say, 5 or 6 lessons are going to go. They're not going to be super, super long, probably 15 to 20 minutes at most each one, just because the content is, for the most part, pretty similar among all of these sections. It's just making the conversions that's usually the trickiest part with a lot of this stuff that's upcoming. So I just wanted to give you a heads up. In any case, I hope you have a great day, and I will be seeing you around next time.